the galvanic isolators are rated in amps. This is for 30 amps. The capacity of the galvanic isolator in amps should be according with the capacity of the main breaker in amps. The main breaker on the AC panel. The capacity of this breaker should be exactly the same with this capacity. We are going to do different exercises. One is we are going to check the condition of the pedestal. I want to know if the pedestal is in good condition, if the ground is good or not good. Normally in the pedestals you have the main outlet on top, and in some cases you have single outlets on the side. Single phase outlets on the side to connect vacuums, the small pumps, and you have the main outlet for 3-phase or double phase here in the principal. That's okay? And you have in the side the breaker, and you have single outlets. And additionally, you have hotline, neutral, the white one, and 1 bar here for ground. 1 bar for ground, 1 bar for neutral, hot 1, hot 2, and hot 3. Because this pedestal is 3 phases. You see? Oh, I want to know in this pedestal if I have good ground. I check the voltage in between hot and neutral. Hot and neutral, 120.3. In between hot and ground, 120.0. This is good, the ground?
Yes.
Yes, the ground is good. The ground is good. What happens if the reading between any hot and neutral is 120.3, and between hot and ground 116?
Not good.
The ground is not good.
The ground is not good.
It's simple. Oh, Mr. Lopez, the manager of the marina, they don't allow that I remove this cover in the pedestal. Okay, but excuse me, you have in the side 1 single outlet? Yes, I have a single outlet. Okay, in the single outlet, you see the single outlet? Normally, I have this. I prepare one extension like this with the cables exposed. The ground, the hot, and the neutral. You see? Hot, neutral, and ground. And I connect that one in the outlet because it's easy for me connect the multimeter here. In some cases, it's difficult to introduce the legs of the multimeter in the outlet, you know, because are too thicker, no? Okay, with this is better. And I am going to do the reading. That's the neutral, and the neutral should be connected here to the ground. How much is the voltage of this pedestal? 122, no? Pay attention. I want to know the frequency of the pedestal. Look, this, what is the function for frequency?
Hertz.
It's hertz. You see? Hertz. Hertz, the bottom one. Hertz. Okay, hertz is the yellow one. Ah, okay. How much is the frequency in this pedestal?
60.
60 hertz. 60 hertz. 60 hertz. Oh, wow. It's simple, no? The voltage or frequency. That's it, 60 hertz. Pay attention. Why is important know the frequency of the pedestal? Because in some cases I need to calibrate the frequency of the generator with the frequency of the pedestal. Look at this. The customer complains. When my boat is connected to the shore power, everything is perfect. The lights are good. I touch the pumps, I touch the motors, the fans. But when my boat is with generator, is running with generator, the lights are blinking. I touch the pumps, freshwater pumps, sanitation pumps, or they are too hot. That indicate what?
Low frequency on the
That the frequency is not equal. It's not equal. This one apparently is good, and the frequency of the generator is not good. In that case, what is the process?
Fix the RPMs.
You need to verify how much is the frequency produced for the generator, and with the generator running, adjust the frequency to keep both frequencies equal. I'm going to explain that process in the chapter of generators. For that reason, it's important check periodically how much is the frequency of the pedestal. Because I am sure, I know my boat, that the frequency produced for my generator is 60.0. If this pedestal is 57 or 58, 100% sure I will have blinking lights or hot motors. Yeah, and I can damage equipment. You enjoy? Okay, now we are going to check the galvanic isolator. Okay, where should be located the galvanic isolator? In between the shore power, inserted in the ground. I need cutted the ground and inserted. I need cutted the ground and inserted in series. In between the outlet of the boat and the main bonding conductor. The main bonding conductor. It's clear that this is the main bonding conductor, guys?
Yes.
All right. Now, where is located that main bonding conductor in a typical boat? Normally, you know, imagine a medium big boat with two engines, and you have a space in the middle to work, no? Space is narrow space. And you have stringers where the motor mounts are located. Normally, along the stringer, you have a piece of metal, exposed metal, pure metal, and all the metallic elements are connected to that piece of metal. Yeah? In each stringer, you have one here or here, and finish. You see, you go out at the end, and you see the connection, the external wire connected with the zinc outside. This is the galvanic isolator. I have suspicious that my galvanic isolator is damaged or is broken. I need to verify if the galvanic isolator is in good condition. What is the process? I am going to verify with the multimeter if the galvanic isolator is good or not good. Be careful with this. How many terminals have a typical galvanic isolator? No more. No, Mr. Lopez, I have a galvanic isolator with 3 terminals.
Oh my God.
No, because you cut the ground and you connect ground here and ground here. It's clear? Only one input and one output. I mentioned this because one day I visited a boat in Miami, and I found that here where the galvanic isolator should be installed, I found that this.
a.c.r.
This is the a.c.r. And they connect one here, other here, and the middle nothing. Looks similar, no? Hey, my friend, this is not. Yes, sir. Oh, my friend. Because you know, the people create confusion, the manufacturers, because the name of this for some manufacturer is multi-battery isolator. You remember? It's battery stabilizer. Why they name battery isolator? It's not a battery isolator. It's a battery equalizer. It's a battery stabilizer. The name creates confusion. It's not isolator. Some people lose like isolator and put that one like isolator. It's not an isolator. The galvanic isolator is this. And they say galvanic isolator. You see? Galvanic isolator in the label. Be careful. I found it 2 times an a.c.r. installed here. This is an a.c.r. And the purpose is keep both battery banks equal charge. All right. This is the galvanic isolator. And I am going to check if the galvanic isolator is good or not good. Normally the people say, no, to check the galvanic isolator, I need the multimeter in the function continuity. Beep, beep, beep. And I check, no PP or yes PP is broken or not broken. That's true?
No.
No. You remember internally what electronic devices I have here? Diodes. Diodes. What is the function of the diodes? Block the flow in one direction and allow the flow in the other direction. No, that's the main function. Okay, we are going to check with the multimeter in diodes. What is the symbol for diodes? Is this. In this direction, the current flow. In this direction, no flow. That's okay? All right? Okay. Let me check. Where is located the function diodes? Here. Can you show to me? Where is located the function diodes? Diodes, mama. It's that one, the first one. The first one. Because the second one is, the yellow one is, the second one is capacitors. And the first one is diodes. We are going to use both of them in this class. Today we are going to use the function diodes with that symbol. Okay, in diodes, I go to that function. Now in diodes, I am going to check what happened. I am going to put my multimeter here in diodes, and I am going to disconnect the galvanic isolator from both sides. Disconnect the galvanic isolator, the ground. I remove the ground in both sides. And now, because internally you have a lot of diodes and capacitors, probably the capacitors have energy, it's a good idea discharge discharge the equipment. How I discharge?
Rounded to each other.
No, with a chord. I make a chord between this point and this point, a chord, yeah? I discharge the current. Okay, right now is discharge, and now I am going to read in the function diodes in one direction, the flow of current. What current? The current of the battery of this device. And the current should be going from 0, this element in diodes, read volts. What volts? The voltage of the battery of the equipment. And the volts should be going from 0, 0.1, 0.2, 0.3, maximum 0.91 volts, no more. If the current goes up more than 1.1, 1. You need to remove the multimeter because you can damage the fuse of the multimeter. This is an indication that this one is damaged. Should be going maximum 0.9, 0.99. And after that, I am going to discharge again, and I am going to check in the other direction. And once again, 0.1, 0.2, 0.3, 0.9, and stop. In both directions, it's good. Or 0.1, 1.1, 1.3, no, it's damaged, all right? Or if when I connect, the reading immediately is 0 and no move it, it's in short. Of if when I connect, the reading goes directly, immediately to 0.9, it's damaged. Okay, we are going to check this one. All right, in one direction. Okay, 0.1, 0.2, 3, 4, 5, 0.6, 0.7, 0.8, 0.9, 0.92, and stay over there, 0.93. You see? It's going up? No more, no?
No.
Okay, in one direction is good. Now, remember, black here and red here. And now I am going to do a chart again. Why? To discharge, no?
Discharge the capacitor.
Discharge the capacitor. Okay, and now I am going to flip. Once again, from here and here. Okay, 0.1, 0.2, you see? And I'm going to wait if in both directions is
0.9.
is 0.9, 0.7, 0.8, and once again stay in 0.9, 0.93, and stay over there. You see, guys? All right. What this galvanic isolator is good. What happens if when I try to read stay in 0? It's open. If when I connect immediately go to 0.9, no, it's in short. Or immediately go to 0.45 and stay over there is damaged. The reading should be progressive, no? From 0 to 0.9. Simple. Remember that internally you have a diode, no? The diode, pay attention, how you check if a diode is in good condition or not good condition? Guys, look, you have a diode here. You see that the diode have one band black, white, you see? You see? This is indicating that the direction is this. This is this band. In this direction, is flowing. In the other direction, no. Okay, let me check. I am going to connect this one here. In one direction should be some voltage, 0 point something. In one direction is 0.52. Let me flip. In the other direction, 0. In the other direction, 0.5. This is the diode. Okay, guys. Now we understand the galvanic isolator. No, it's a great equipment. If I have pay attention, the galvanic isolator is mandatory in a boat. Mr. Lopez, I have a small boat only with DC panel and one outboard. And I don't have a bonding system dedicated. I don't have bonding in my small boat, only with DC current. Yes, it's normal that in small boats, only with DC current, you only have sinks to protect the motor, the outboard. No? Why? Because internally in your boat, you don't have a lot of metallic equipments, and you don't have AC current. You don't have AC panel. Huh? You don't need a bonding system. Excuse me, Mr. Lopez, I want in that small boat to install a permanent battery charger, and I am going to install a small air conditioning equipment for my family. Okay, in that case you need to create a small AC panel, and the recommendation is create a bonding system. Immediately you create an AC panel and you install AC equipment, you need a bonding system. Okay, and now because I have bonding system, excuse me, because I have AC panel, and the AC panel receive power from the shore power, I need install a